morning. Thanks everybody for coming to the seminar. This seminar is about experimentation as a service, 6G experimentation as a service. What is it? So the way in which we understand experimentation as a service in the Plaza 6G project, which is one of the UNICO R&D projects that the CDC was granted. My name is Josep Mangues, and together with Sergio Barrachina, we're going to try to explain you how we understand this experimentation as a service on behalf of this team. So this is people working in the Services as Network Research Unit. So there's a lot of people involved in one way or another in this project, as you can see. So you can deduce that this was a really relevant project for us. Right? It was key, and we hope it's going to be also for the CDC as a whole. Right? So in addition of the technical tasks that were developed, this kind of project, as you may know, have some complexity in management. So that's why the admin team also helped a lot on this. So thanks to all these people, and hopefully Sergio and I will be able to convey you all the hard work that is behind this project. So if you want to keep a few messages of this talk, this would be the ones. So the first one is that Plaza 6G, as we were mentioning, is about experimentation as a service. So it means that in the same way that you go to Amazon Web Services, for example, and you get some cloud resources and then you play with it, we are planning to offer on demand the same kind of service and experience of service, but for experimentation in mobile networks in general, in particular 5G, 6G, whatever generation. So this is what we mean with experiment as a service, right? Offering a kind of easy to use framework and interface so that you can configure your experiment without much effort, right? So usability is a key design concept here. And we do that by automating, so making the life of experimenters easy. We do that by automating the lifecycle management of this experiment. So meaning that once you have a clear idea of what the design is of the experiment, what you want to do, the system will not only deploy it, but will allow to execute it, will allow to manage it, to give you access as experimenter to key nodes of your interest, and then to gather the KPIs of interest for your experiment at the end of the experiment. And we do that with different flavors of technologies. So concept and the framework is generic enough so that can be applied to different generation and those to come, right? Then, as part of this automation and this on-demand experimentation service offering, one of the key things that we try to do is to minimize the time devoted to experimentation, or in other words, like that you could focus exactly on what you're interested in, right? And the system does the rest for you. So we're trying to do that not just for our internal purposes, but also for use by external users, so that, for example, a vertical could focus exactly on tuning the application, but then forgetting about how the 5G network is configured and so on, and just gather the relevant KPI, right? So they can focus on their core business. And then all this is running in over the extreme testbed of the CDC. So we already had it before this project, but it has been substantially renewed and extended. So you will see in Sergio's part of the presentation what are the key assets that we added that makes these an even more advanced infrastructure substrate. And one of the key features that we are adding with all these framework and the new key assets is adaptable environment control. What this means is that we will be able to decide what level of detail you need of the network nodes, for example, and what kind of control you have on top of them. So be it like more high-level models, like in simulation, or closer to real environments, like in our outdoor setup, right? And then, yeah, all this information and more to come in the website that you see below, right? Now, we organize the talk in this way. So we're going to give you a bit more of context so that you frame the discussion of why we did this project, why we carried out this project in the first place. Then we're going to show you the graphical user interface we defined and how we try to ease the life, so improve usability, as we were mentioning. And then, since it takes a while to deploy, meanwhile, we're going to explain you these key assets that we were mentioning in terms of the data center, the private 5G network, or the anechoic chamber. You will see an experiment that we run also over the air, including roaming in this case, which is a more or less complex scenario. And finally, we will see the results of the demo. We will conclude the talk. Now, let me give you the broader context of the project. So this is, as we were mentioning, this is part of the UNICO R&D program. So in particular, the call of 2023. And this is part not of the Agencia Estatal de Investigación. So it's not a basic research project. It comes from the Digital Transformation Ministry, and before that, the Ministry of Economy, right? So it's more on creation of ecosystems. It has a more economic and social impact component, right? So this is also relevant in terms of motivation to carry out this project, right? And this is part, as you see, of the Recovery, Transformation, and Resilience Plan, which in turn is funded by Next Generation EU funds. So, and another important thing is that in this type of project, there were two flavors somehow, the equipment one and the infrastructure one. So in the equipment one, you just bought advanced equipment. In the infrastructure one, which is the case, it was not only about buying advanced equipment, but also about developing the framework on top. So it was not just about only installing the equipment, but also developing this framework that you will see in action on top, right? So we could hire people to develop this framework also. This is what we did. Then the time frame to develop it was starting January 2023 and ending right now. So you will see the outcome of the project. And the other important thing in terms of broader context is the name. So if we had to translate it, so you see the Spanish expression to the right, but in English, that would be something like 6G Experimentation and Innovation Hub. This again links with this idea of the ministry from which it comes, right? So it's the Digital Transformation and Ministry of Economy one. So it's about the creation of an ecosystem. And in turn, this links with the broader context again, right? So this need for exploiting the infrastructure that we as European researchers have is coming to us, like this request is coming to us in many different ways. It's coming at the regional level, like, for example, the GINCH program. It's coming at the Spanish level with this kind of projects, for example. But it has come since long at the European level. There have been FIRE projects that were dealing with experimentation, like Bonfire. There have been 5G PPP projects like 5G Eve, 5G Bini, 5Genesis. Now, currently in SNS, there are these Stream C projects, which are supposed to build this kind of infrastructure that is used by others. And we've been involved in some other projects where the goal was exactly this one, like offering experimentation services. So we are receiving, let's say, from society or from European society, at least the request of giving back to society this kind of, there's a huge investment on this kind of equipment and infrastructure, and it should be offered, given back to society so that they could benefit from it. So this is a kind of broader context of the thing. But all these projects, and we know some of them, in our opinion, just got some good results, but partial results, because still there were many manual steps involved, right? We have used some of them. We have offered experimentation services to other people, and in the end, there are always many manual steps. So we wanted to see how far we can go in terms of improving usability and automation. So again, so that the people that is using the testbed can focus exactly on their core business, right? And forget about the nitty-gritty details of the configuration of the network. So that was the goal. And for that, these are the main concepts that were involved in the project, right? So the high-level ones. So as you see to the left, we are aiming at serving a broad stakeholder ecosystem, let's say. So if we take, for example, verticals, which is in fact the one that we handled. So the typical request we got in projects is, I'm a vertical, I have this application, I want to put it at the edges of the network, so at the core and then at the edge in the device, and you need to tell me, I don't want to know anything about the 5G network that is in the middle, and what I want to know is what is the delay and throughput I'm getting, and if this meets the requirements of my application, right? So this is the typical request. So that's why we designed this also, right? So first key thing to improve usability is this block called Web Platform and API. You will see an example later during the talk presented by Sergio. So we want to offer this kind of easy to use interface to users, be it through a web or programmatically, right? So for development. So this is the API side. Now, once what the experimenter wants to do, what are the needs, is clear and comes through this interface, what the system will do for this experimenter is to generate an experimental slice, which means, same concept as in 5G network, a slice, but in this case, it will preserve cloud and network resources end-to-end and place whatever nodes we need in the system, in this shared infrastructure that Extreme Testbed represents, right? And then we will do it, and this has to do with these different levels of experiment control that we may want in multiple ways, multiple different environments. So you could be fine, maybe if you want to test the scalability with high-level models and putting a lot of users in the system, you're fine with using high-level models of certain network nodes or of some of them. So because with emulation, you put one which is real interacting with some high-level model, right, in some way. But it may be you may need more controlled environments and more detailed control, for example, for the wireless environment. And through our anechoic chambers, for example, we can programmatically control the attenuation between different devices, right? So we have full control of that. This is what we mean with controlled lab. But before going to production, for example, you may be interested in testing in closer to real environments. And we have our own outdoor environment deployed in the two buildings of the cities in this campus, right? And this would be, a level closest to reality. Now, once the experiment is run, we will collect the data sets, the metrics, and so on, so that the experimenter can check. And then we were already talking about this end-to-end life cycle management. So these two key concepts that we have at the top about once the design is clear, about executing the experiment and managing it, having access to whatever node you need, gathering the KPIs. All this is what we explained about lifecycle management. And we have one slide on CI/CD later. So I'm going to talk about it later in a minute. So the building blocks, again, at a high level that we developed, and you will see them in action all together now, are these ones. So we have a user layer, which is the one that is offering this usability, can be through a web interface or programmatically. And then this LLM assistant, we have a really preliminary version for the moment. So it's ongoing work. The final aim of this is to be able to talk with the system in natural language, and in the end, you can do whatever you need just by interacting with the system in a more natural way. So again, related with improving usability and ease of use. Then once the design of the experiment, what you need to do is clear, the next step is to go to this experiment orchestration layer where the brain is this scheduler, which is the one deciding. So knowing what are the available resources in the underlying infrastructure, so the stream testbed, because it's a shared experimentation infrastructure, right? We want to be able to run multiple experiments concurrently. So this scheduler will be the one deciding where to allocate all these based on some kind of experiment repository equivalent to the repos that you may have in the cloud native environment for some images. So in this case, we have experiments defined. And then the experiment modalities we already talked. So the different levels of control that you may have in this environment and different kinds of environments depending on your needs. And the underlying infrastructure, you'll see more details about the features of this one in Sergio's slide. But that's the shared infrastructure on top of which we deploy whatever modality you're interested in. Now, we're talking about the CI/CD, which is another relevant concept in terms of design, how we designed this platform. So the idea here is that this experiment as a service, we want to, again, ease the life of people so that we adapt to the way they work, not the other way around, which is the perception we had for many of the other projects I was mentioning before, right? So the way the cloud native community works, for example, verticals, is they have this CI/CD philosophy where they are continuously developing code. Once they do some improvement, they push the code to the repo, and then they build it, they run unit tests, they build and package the thing, and then they move to integration tests, so potentially with other building blocks, and acceptance tests. So the key thing that we are proposing here is that as part of the acceptance test, so it's not a local acceptance test, which is a typical thing they do, it's a more advanced acceptance test where you put this experimentation service in the middle. So they can actually test their application end-to-end over whatever environment we can offer in terms of experimentation as a service. And once they get the results and they pass the test, so this is accepted, and then they go to staging, like kind of pre-production environment before going actually to production, right? So let's say the key message here is that we adapt to the way people work and not the other way around, which was what other projects did and possibly are doing. And now we're going to go to the more, let's say, interesting part where Sergio will show you how things work. Okay.
Yeah, thanks a lot, Josep. Good morning, everyone. So today I will talk about two things. The first thing is some of the key assets that we are including in the testbed, right, under the umbrella Plaza 6G. And also I will show you a couple of demos on the working prototype we have today. Okay. So as Josep was mentioning, there are two ways to interact with the platform. One is through APIs, and the other is the regular website. So this is how the front end looks like today. This is our prototype. And let me briefly show you how it feels like. So here's the website. So the user or the stakeholder will access to this website. Well, we have here a preliminary version of a chatbot. Here we can ask, right now are very generic questions, but anyway, we can say, hi, what is Plaza 6G? Or whatever. So in the backend, we have an LLM, which has been trained for this specific task, but we are getting more fine-tuned versions, let's say. So here we can keep talking if we want. I don't know who is the principal investigator or whatever, right? So you know, we can let it answer. The important thing here is that once you log in, wait, let me put my glasses on. Okay, when you log in, you can do different things, right? You can set up a new experiment, you can check your current experiments, or you could even access current experiments directly. We also have some blogs to make it easier for the user see how to interact with the platform. And for example, right now, yeah, I believe we have a couple of experiments. So these experiments were already requested and they are now operative. For example, here we have a network with free 5G core as the core network, and this entails 4 different VMs, right? We can access them. We can even delete the experiment if we like, so on and so forth. So right now, let me set up just a very minimal experiment to show you how it works. So we could ask, for, I don't know, for example, for a VM Plaza 6G seminar. Right, we put a name, and then there are a bunch of things that we can select. We are in the process of making it as easier as possible, but today is more or less, I would say, more or less intuitive. We're working even more on that. But you can select pieces of the experiment one by one, or you can even try with templates that I will show you later, right? But for example, we can select some infrastructure. Here, for example, if we want, let's say, some researcher wants just a VM, and he or she does not have enough power in his local lab or whatever. So you can select a virtual machine here. You can fill, well, the different fields. Apart from VMs, maybe someone has some problems deploying Kubernetes or whatever. So you could even select a Kubernetes flavor for yourself. We are introducing GPUs as well, right? So maybe you want to use GPUs and you don't have it. So you can use it here. I don't know, let's call this VM seminar or whatever. We are introducing a bunch of operative systems. I don't know, we can pick any of those. RAM, I don't know, maybe 8. This size 20, 4 cores, right? There are 2 possible ways. So you could deploy this VM because you want to access and do things on your own, or you can even upload the scripts and you forget about accessing the VM because you don't need it. No? Then there are metrics that you can check by default, and that's how it looks, right? So once we have prepared the experiment, this experiment is very simple. We just simply click start. Right? Well, here we have a summary of what we're requesting. We submit it. And now we have already our experiment being processed. So if we go here, we can see that this third experiment is being processed. Right? Before moving on, let me just show you how a much complex experiment will look like, but I will not generate it. No, I know. What is the name of experiment? Something. Okay. So in here, if you want to test something that is more complex than a VM, right? For example, you want a 5G network. A 5G network is composed of multiple elements, and you may not have the experience or you're not aware of which elements are. So you can simply rely on templates, right? For example, let's say that you want to use some over-the-air experiment, right? So you can use our templates here. So you go here. Here we briefly explain how it would look like. So with these templates, you can pick up a real smartphone, for example, an Android. You will be connected to a real GNOD, for example, a Marisoft or whatever. You can get to select your 5G core, and you can even ask for a data network. So rather than going directly to internet, maybe you want to test some edge research or whatever, right? So you can go here, you can ask for a data network, you say one, you can select different cores. Up to this date, we have 3, but we're including more. These ones are open source. We also have a couple which are commercial, and so on. So this is the way that you would generate a request for an over-the-air experiment, right? So let's leave the experiment running, and let's go here. So we will come back later to the website. So that was a taste on the front end. Now, under the umbrella of Plaza, we have been including different key assets. Today I will show you 3, but there are more, right? Just for the sake of time. So the first one is about extending our testing platforms that we already had. These are some numbers. So we have like I would say a very powerful data center. We have 3,000 cores, 20 terabytes of RAM, a bunch of GPUs, which can even be virtualized, so we can share between users. The networking is also pretty powerful, so we have lots of switches. We can manage up to 200 gigabit per second rates. We have special devices for ORAN, right? And we also have some time-sensitive networking switches. So by opening all this, we let the community do research, and we can do research as well. And as for the storage, yes, we have plenty of storage. Everything is centralized and is redundant. So data sets and metrics are safe. Apart from the pure data center, of course, we are offering XG, 5G, 6G, and beyond, the capabilities and devices. And here we are just showing some of them. More details on this will come in a follow-up seminar. And what is the idea? So we try to follow 5 foundations and principles. We want that the platform provides scalability. So we will have lots of users, lots of data, and we want that everything works fine. We want isolation, right? So we have user A cannot interfere with user B. We want it to be available. This is why we have it. We have redundancy, we have security, and so on. We want flexibility because there are a plethora of types of experiments that someone could request. And finally, we want observability, right? We want to know what is going on in the full life cycle of the experiment. So under the hood, I will not enter into much detail, but this is operating like, I would say, like a industry company data center, right? At least we are trying, but it looks like that. So we are relying just exclusively on open source software. This is very good. So the main tool that we are using is the well-known OpenStack. So we have our own data center, let's say, and we're using OpenStack for that. But also we have a bunch of tools, for example, for infrastructure as code. We're integrating Puppet, we're integrating OpenTofu. As for the muscle, we have virtualization with KVM. We also count with NVIDIA GPUs, so we have CUDA. We integrate natively Kubernetes and Docker, right? These days, this is a must. And yes, for observability, we use also open source, Grafana and Prometheus, which are very powerful tools, so everything can be monitored. Not only for the experiments, but also for ourselves to keep the data center on track. Second asset that I will be talking today about is our private 5G network. This network is outdoors. So we have a couple of base stations. We have one of the base stations in this building. This is building B6 at CTTC, Park Mediterranean, for those of you that are remote. And we have another one in B4. So you can imagine that we have two base stations in two buildings. These base stations are composed of different radios. So we are supporting different bands. Well, here we have the details. We have M40, M78, and we 1/2 millimeter wave. And we are integrating these base stations with a couple of cores. And as we will see later, this allows roaming and any kind of experiment that you can think about in the real world, let's say, right? By the way, these cores can be proprietary or commercial, but it can also be integrated with other open source code, right? Of course, the radio are commercial, right? We have Nokia's, but all the rest can be. So if there is anyone developing a core, she or he could integrate it with our platform. These are a couple of figures of the installation. Essentially, we have three buses, as we were saying, and one of the base station is providing the millimeter wave. This is how it looks like. Okay. To this date, we are performing the final test with the vendor, so it will be available soon. Let me finish the talk on the assets, talking about a very special one. We have installed this multi-anechoic chamber. This is something very unique, actually, in the world, right? What this chamber provides is 4 environments, which can be completely isolated or can be completely, let's say, communicated if you want, right? So if you want to place some device here and you want to connect it with some device here and forget about these 2 chambers, you just can play with attenuations and you will have this path here. If you want this path, but also this path, you can do it as well. So you have kind of exponential types of experiment that you can do. Here we have some details, but essentially the key point is that each of the environments is able to work at sub-6 gigahertz, but also in millimeter wave. So this is very good because if you are testing a new radio device or whatever, maybe you want, well, most likely you would like to have a controlled environment, so you can have it here. Right? We will see a quick demo on this in a couple of slides. I think we're good in time. Yeah, this is some example of the experiments that you can perform with these anechoic chambers. As I was saying, there is an exponential number of test variables. So I don't know, for instance, let's say that you want to try roaming. So you might want to try roaming from one G0D core to another G0D core. Maybe you are in the home network, but then you have 2 or even 3 potential visitor networks and you want to see or to test some algorithm, okay, which is the best one according to SNR or whatever. This is just an example. You can even think about more physical layer stuff. So you have your radio and you simply want to test how other devices could interfere. And here you can think about anything you want. No? You can think about Bluetooth, other 5G networks, millimeter wave, whatever. So this is a very powerful tool because you can test things not only on paper, but let's say pseudo real world, right? With a controlled environment. And this is very important because this allows reproducibility, right? If I do an experiment in this anechoic chamber and then another person do the same, we will have exactly the same result. This is very good. Just to show you some of the things that we can do with this anechoic chamber, I will show you now an experiment that we just conducted for this very seminar. So in here we have a UE. This is a regular Android phone. In the chamber at the right, we have a G0B. This is an Amarisoft Callbox Mini. And in here we have another Callbox Mini, right? And we will see a roaming scenario. So you can imagine that this UE is potentially having access or coverage to these two radios, right? We will manage this coverage according to the attenuation that we're controlling. And of course, these G0Bs are connected to something, which is the core. For this particular demo, we are showcasing the Kumu core 5G core. This is commercial, but we can plug any other core. And we will see roaming that takes place in this way. So we will be first connected to this G0B here. So we'll have the home network here. But at some point, we will reduce the power, or more than reduce the power, excuse me, we will increase the attenuation here. And we will decrease the attenuation in the other path. So a roaming event, let's say, will be performed, right? So the 5G core will notice that the UE wants to connect to this visiting network. The 5G core has been configured to accept requests from this home 5G core, and it will work, right? So this is demo time. We plan to do that in real time, in real life, but just for the sake of time, we have some video prepared here. Sorry. So in here we have the UE. This is one of the G0Bs. This is the other one. And here we will play with attenuation. This is the anechoic chamber, right? And we will see what happens in a second. Let me play it. Yeah, so we have our UE. We will leave the airplane mode. So we are connected to the first G0B here, right? And we will show just some simple traffic. By the way, here in the phone, we can see that we're connected in the home network. It's called CTTC. And now we will see some traffic, right? So here we are pinging the internet, Google DNS. So this is the traffic experience in the radio, and we will play YouTube just to show a more common use case, let's say. So we will see some fancy animals, but of course, before of that, we have an advertisement. This is real life, right? We want real life. Okay. So this is the traffic. Now what we will do is we will increase attenuation in the path to the home network, and we will jump to the visiting network. So here we are increasing the attenuation, right? So our phone now has no coverage. By the way, the video is still reproducing because of buffering effects on YouTube. This is not on us. Okay. But you can see here that there is no traffic. So to make things a little bit faster, I think we will now, enter in airplane mode. But you can see here the traffic is no longer working. So now, we are entering in airplane mode. And then we are leaving the airplane mode again, and we will see how we are connected to the other network. So what happened here is that the UE, by the way, you can see here that the phone is noticing this roaming. What happened is that we lost coverage to the home network. Then the UE requested an attachment to the visiting network, and since both cores were configured for that purpose, the roaming was okay. And that's it for this demo. And if you remember before, I started with the website, right? So let's come back and take a look on how it looks like. Okay. This is demo time again. Right, so experiment. Okay, yeah, I don't want to. Okay, right. So here we have different experiments. For some reason, this experiment has not been completed. Maybe there is some issue in the backend, but well, you can believe us that. But yeah. Okay. Yeah. Sorry. Yes. Yeah. This is the one that I didn't finish. Yeah. This is the one that we generated, right? So this is the VM that I was requesting, and now we could access this VM, right? But rather than access this VM, let me access some fancier experiment. So for example, in here, before the meeting or before the seminar, I just requested to have an Open5GS network. So the run here is simulated. We are using URL just for simplicity today, but we are also adding a data network. So in here, we can provide our vertical services or whatever, right? So just to show you a quick example of what can be done, let me open different tabs. So in this tab, I will access the UE. So in this case, the UE is just simply a Linux running URL, right? So this is the UE. Let me also access the core, right? This is the core. The core in this case is also running in a VM, but it could be running in a bare metal or even in a Kubernetes, right? And let me access also the data network. So in this case, the user might want to have some graphical user interface because, I don't know, maybe you want to play a video or whatever is the reason. Maybe the user feels more comfortable with that. So we are also providing graphical user interface access, no? So let me remind that all this setup of 4 VMs and having a network running and so on was generated with a single click in the website, right? So people can play with 5G and other stuff without even knowing what is 5G, no? More or less. Okay, so now here we can do some ping. So for example, we can ping the internet. And in this case, we have the simulated UEs pinging the internet. So from our lab, we are able to go to the internet. This is fine. Let me show you that traffic is actually going through the 5G core, so through the UPF, right? This means that traffic should go should be forwarded via this VM because in here we are running the UPF. Yeah, sorry for the command lines. Anyway, so here we have a UPF that will get this traffic and will populate it to the internet, right? So we can show you that with TCP/DAM. And here we are confirming that traffic is going through the UPF. So we are actually using a 5G network, in this case, Open5GS. No? This is the data network. And in here, we can have any vertical, video server, virtual reality, a health application, whatever you like, right? So we can access not only the internet, but we could even access this local network. No? Let me quickly check what is the IP because I don't remember now. So we could have some service running in our local network. I'm sorry, I don't have a mouse. Anyway, so we can pick not only the internet, but also our data network, right? Paste. Right, so imagine that in this data network realized as a VM, we have some service, so we can access directly, and all the traffic is kept in the experiment, no, in the lab. right? Just to finalize, we are providing also metrics that the user can check at any time. So for example, if we go to the 5G core VM, right? Here we're providing by default some very simple and preliminary metrics, like for example, CPU, memory, storage, and even the traffic, right? This is what we call normal metrics, but the user can even, let's say, deploy advanced metrics of that he or she can define, right? Yeah, so I think this is pretty much it. Let me finalize by terminating the experiment, so completing the lifecycle management. So for example, we can delete this. We can delete this experiment that we just used. So that's it. Experiment is concluded, right? So again, what we have seen with this small demo is that users can ask for very complicated things with just a one click, right? And this is very good, and we are kind of proud of that. To finalize, I think we are more or less good on time. What we show you today is a taste of Plaza 6G, right? The introduction, the motivation, and even a working prototype. And Plaza 6G essentially is making the extreme testbed a powerful data center, a platform that is providing XG devices for experimentation, 5G, 6G, even Wi-Fi. And the third leg of this extreme testbed is that we are introducing AI to enable this experiment as a servers with the focus of making the platform usage as easier as possible for the user, right? Why is this project relevant? Because we are transforming complex experimentation in something that is easy, but is also on demand, right? So you don't have to build the complete lab on your premises. You can rely on us. Okay? And this is very good, not only for researchers, but also for the CI/CD pipelines that Josep was mentioning before. Where are we today? Well, we have a fully functional prototype that we showed, but we are transitioning to make this publicly available, right? We're working on that. And of course, there are always new features that we want to add. And as for these new features about the roadmap, we are expanding the hardware integration. As I mentioned, today we have talked about only 3 key assets, but we have a lot more to come, and we're integrating those assets, and also we are advancing on the LLM capabilities, right? At the end, what we want is that the user is able to prepare the whole experiment simply by natural language, right? So that you can ask the assistant, I want a 5G network, tell me which is the best one for my needs, how is my experiment doing, right? And so on and so forth. And here you have the website. At this point, we have a preliminary website. We're working on making this one that I show you publicly available soon. And yeah, I believe that's pretty much it. So if you have any questions, okay. Thanks a lot. I don't know, maybe in the Teams or
Any question here or remotely? I hope it is because everything was clear.
Mm-hmm. Yeah, let's hope. Okay.
Okay, so if there are no questions, thanks everybody again for coming, and hope you enjoyed. Thank you.
Okay.